participate. You have to pay attention. Here we go. So combining like terms. So we're just going to kind of start back from basics because like I said, last time I felt like where the worksheet didn't work out, I could have taught better. So focus. Everybody up here. Combining like terms. So I don't want you working on the worksheet. Just watch for a minute. You're going to have plenty of time. You'll finish that in class. Just calm down and look up here. So combining like terms, you can combine things that they're alike. So 1 heart plus 2 hearts is how many hearts? 3 hearts, correct? If you have an apple and then you add 2 more apples to it, you have 3 apples total. So this would be 3 hearts, correct? Everybody. So if I have 1x plus 2x, how many x's do I have? 3 x's, correct, everybody? Okay, good. Now if we have negative x plus 2x, how many x's does that leave me with? Negative 1 plus 2 is? 1x, right, guys? Think. Guys, think. If you have negative $1 and you add $2, how many dollars do you have? $1. Everybody good? So we have 1x, so I'm just going to write x. Is everybody comfortable with that? Think before you act. Think before you say for a second. Negative 1x minus 2x's is how many x's? Negative 3 x's. Correct, everybody? So you got to really focus on this and not make sign errors. Because what happens is I know students get a little careless. They see a 1, a 2, and assume 1. Does that make sense, everybody? So just really watch. So we have 3, think about it, 3 x's minus 7 x's. How many x's do we have? Negative 4 x's. Correct, everybody? Okay. Questions on that? 3 minus 7 is negative 4 x's. Okay. Cool. Now, inverses undo each other. An inverse is something that undoes something. So everybody, addition undoes subtraction, and subtraction undoes division. So we're going to be solving by applying inverses. When I say apply the inverse, that means undo it. So I'll say that again. Addition undoes subtraction. Subtraction undoes addition. So if I said to you, solve, notice there's an equal sign. That's how we know we're solving. If I said to you, solve for x, do you see how we need to get x alone, and it's x plus 2? Everybody, do you see that, yes or no? Participate, and we're going to go way quicker. Yes or no, does everybody see how it's x plus 2? What undoes addition? I just said it. Subtraction. So how can we undo plus 2? Subtract 2. Now we're going to subtract 2, so we've got to do that to both sides of the equation equally. Now look. Over here on this side of the equation, we would combine like terms. X doesn't have any like terms. Positive 2 minus 2 is 0. So I'm not going to write that because everybody sees. And that's equal to, now combine like terms on the right. 0 minus 2 is negative 2. Now your next step is get x alone. Well, isn't x alone here? So we've solved for x. Does everybody understand? Okay, x minus 2. What undoes subtraction? Addition. So we would add 2 to both sides of the equation. Now combine like terms. X, no other x's. Negative 2 plus 2 is 0. So we did the inverse correctly. And that's equal to 0 plus 2, which is 2. So x equals 2. Okay, multiplication undoes division, and division undoes multiplication. They're inverses of each other. So look, this is 2 times by x. Correct, everybody? So if I said to you, solve for x, we need to undo the multiplication. What undoes multiplication? Division. So we would divide both sides of the equation by 2. So now look, 2 divides by 2 and becomes a 1, correct? 1 times x is just simply x. That's equal to 0 divided by 2 is 0. So our answer is 0 here. Now look, this always throws people for a loop. But read it. X divided by 2. What undoes division? Multiplication. So we're going to multiply both sides by 2. Now look, 2 divides by 2 and becomes a 1. So we have x is equal to 0. Does everybody see how these inverses undo each other? Questions on that? Okay, now let's kind of put it all together. So these are literally the step-by-step instructions on how to solve a linear equation. The first thing you're going to do is combine all like terms on each side of the equation. So look at my example and focus. Do you see how on this side of the equation, we have 2x and negative x? Guys, We need to combine those, not using inverses because we're just combining like terms. So let's combine like terms. 2x minus x is 1x. Now I'm going to cross those out. Didn't we combine those two? Now 3 minus 1 is positive 2. So I write plus 2. Now we still have our equal sign, and I'm going to combine like terms on this side. Oh, x and negative 3x, we're not going to do inverses. We're not moving it from one side of the equation. We're just combining like terms. X minus 3x is negative 2x's. So I just took care of those. And then we have our plus 5. Does everybody understand first step? Okay. Now our second step would be get one variable. We have two variables. Get one variable by getting the variables on one side, the same side of the equation. Now to move from this side of the equation to this side or this side to this side, we have to use inverses, correct? Just like we just did. So then from there, moving across an equal sign, you must use the inverse. So look at this example. All of my like terms are combined, but now I have an x over here and an x over here. That's a problem. We want one x. So let's bring this x over here. You can't just float it over. You've got to use inverses. What undoes positive x? Subtracting x from both sides. So now look, over here you just combine like terms. 2x minus x is x. Negative 3 is still there, is equal to 1. And now we're to our third step. Now that you have one variable, simply solve for x using inverses. So what undoes subtraction? Addition, right? What undoes subtraction? Addition. So now we would add 3 to both sides of the equation up here, correct, everybody? I was finishing that one. So x equals 4. Okay, so if we're here, we have one variable. What undoes multiplication? Divide by 3, divide by 3. So x equals negative 2, right? Negative 6 divided by 3. Okay, and then right here, don't let this freak you out. What undoes division? So we'd multiply both sides by 3, and we would get x equals negative 6. All right. Does that help a little bit? Yeah, once we have x equals, we know we're done. Good. Okay, so now I'm doing all my examples off your worksheet. So I'm going to do a couple examples, and then I'm going to give you the rest of the time to finish. So stay with me. Focus, people. And then also remember, it is an expectation to have a graphing calculator. So if you need to go home over the weekend and go tell your parents, I need to rent a graphing calculator from Westlake for $20. Please do that. Does everybody understand your expectations for the class? Not an option. If you can't handle that, you need to come talk to me. If you can't handle that, you can't be in the class. But if you can talk to me and then I know, okay, I can work with you, does that make sense, everybody? It's all about communication. Here we go, solve the equation. So looking at number 1, remember, you've got to think of your first step. Your first step is look on the left side of the equation, look on the right, and combine all like terms. So let's look at this one. Negative 20, nothing to combine. So rewrite it, guys, show your work with you. Negative 20 is equal to, you should be writing this. Wait a minute. Sorry, wrong one. I'm finding new students, but here they are. All right. Sorry about that, Alec. Okay. All right. So looking at this, we have negative 20 is equal to. Now we need to combine those two. Think before you do it. Negative 4x's minus 6x's is how many x's? Negative 10x's. It's not a trick question. You're absolutely right. We've done the first step. Now, the next step is, if there's one x, solve for x, using correct inverses. We need to get x alone. So what undoes multiplication? Division. So we're going to divide both sides by negative 10. Now we have negative 20 divided by negative 10, which is, everybody? 2. A negative divided by a negative is a positive, and that's equal to, those divide out to become 1, so we have x. Now x is completely alone, so we're done. X equals 2. Questions on that? Okay, let's do number 2. The first step is combine all like terms on the left and on the right. Not using inverses, just combining like terms. So right here we have a 6 is equal to. Over here we got to combine like terms. So negative 2n, there's no other n's. So I'm going to write negative 2n. Is everybody comfortable? Cross it out. This is what a lot of people do on accident, so let me show you. They'll see this negative behind 1 and think -1, but a negative would be in front of 1. So this is 1 plus 5, correct? Which is +6. So we're going to write +6. Is everybody comfortable? My next step is to see if there's two variables. Well, there's only one, so we're golden. Get x alone. Get n alone. Using correct inverses. You got to do it in the correct order. Don't just divide by 2. That's wrong. Your first step is to, subtract 6 from both sides of the equation. So we get 0 is equal to, look, 0 is equal to, over here we have -2n, correct? Plus 0. So I'm not going to write that. And now we're going to solve for n. So we're going to divide both sides by -2. And n is equal to?
0.
Okay, we good? Okay, cool. Okay, let's go a little bit faster here. Let's look at number 3. So first of all, notice, the first step is combine like terms. No like terms over here, no like terms over here. Notice we have 2 x's. That's a problem. We need to combine them. But they're on different sides of the equation. So to get from one side of the equation to the other, we do have to use inverses. So I'm going to choose the smartest, easiest way possible to go about this. I'm going to, how do you want to do plus 7? Subtract 7x from both sides of the equation. Now focus on this side. Combine like terms. 8x minus 7x is how many x's? 1x. -3, is that a 2?
Yeah.
Okay, -2 is still there, is equal to. Now on this side, combine like terms. Oh, -9, cool. And then our -7x and +7x cancel out. Now look, we only have 1x, and the next step is just get x alone using the correct inverse. That's x minus 2, what undoes subtraction? Nope. Good try though. Addition. So we'll add 2 to both sides of the equation. Now combine like terms on this side. X equals -9 plus 2 is -7. Correct, everybody? You should not just be writing down the answer. You should be kind of showing your work. Okay, let's go on to 4. Notice all of my like terms there's no like terms to combine. Okay, now we have an a over here and a -5a over here. We need to combine them, but we can't just float them together. We've got to use inverses. So is everybody comfortable with saying, well, if that's -5a, I'm going to add 5a to both sides of the equation? Okay, now over here on this side, you're going to combine like terms. 5a plus a is how many a's? 6 a's. We still have plus 5 is equal to, combine like terms over here. -5a plus 5a is 0a, so we're good. And we have +5 left. Then remember, what's your goal from there? It's get the variable all by itself using the correct inverse and correct order. So my first step would be to subtract 5 from both sides of the equation. So we would have 6a is equal to 0. Now we're simply, next step is get a alone. So what undoes multiplication? Divide both sides by 6. Therefore, a equals 0. Okay, only a couple more examples and then I'm going to just let you go for it. Stick with me, looking at 5. This is a really interesting one, okay? So looking at this, all of our like terms are combined, all of our like terms are combined. So then from there you'd say, I need to combine my m's, but you can't just float them together. We've got to use inverses. So I'm going to go ahead and subtract 4m from both sides. So now look, on this side of the equation, we're combining like terms. Isn't that -4? 4m minus 4m is 0m's, correct? So we have -4 left over. Now over here, combine like terms. What do we get? 0. Now the next step is get the variable alone. Wait, no variable. What the heck? Well, look at that. Okay, so interesting enough, when that happens, look at it and say, is that a true statement? Is 0 equal to -4? No, that is not a true statement. Therefore, there is no solution. Now, here's one thing to note. Let's say that happened, our variables canceled out, and we got this. 5 equals 5. Isn't that a true solution? That is true, right? That's not our solution, but that's a true statement is what I meant to say. So if it was a true statement, then it would be all real numbers, which means no matter what number I plug in for n, 1, 2, 3, 4, 5, 6, it's going to come out an answer. Does that make sense? It's going to come out a true statement. So if it's not a true statement, you'd say no solution. If it is, you'd say any number is a solution. Does that make sense? Everything's a solution. Okay, here we go. So let's go on to 6. This is getting a little bit more advanced. If you follow the step-by-step instructions, then it's easy. So everybody, the first step is combine like terms on this side and combine like terms on this side. So look, p minus 1 has no like terms, so rewrite it. Now if you zoned out, refocus it in. Okay, now let's combine like terms over here. Don't just see a 5 and a 3 and say 2, think. 5 p's plus 3 p's is how many p's? 8 p's. Okay, I'm going to cross out things as I go to not miss anything. Then we have our minus 8, correct? Now you would say, okay, well I have multiple p's and I need to have just one p. So we've got to use correct inverses to get from one side of the equation to the other. Let's subtract p, yeah? Subtract p. Now on this side of the equation, those become a 0 and we have left negative 1. We still have our equal sign. Now we have 8 p's minus 1 p's, which is how many p's? 7 p's. And then we still have minus 8. And now we're to our step where we just get the variable all by itself. So my first step is to, add 8, right? Add 8 to both sides of the equation. So we have 7 equals 7p, guys, right? Now our last step is to get p alone. Divide by 7, p equals 1. Good. Okay, go to 18. There's a lot going on here. Notice multiplication and all that is going on. So notice something. You look in your parentheses. Do you see how you can't combine those? Can't combine those. They're not like. Then you say to yourself, okay, what should I do here? Well, this is what you should do. This is negative 3 times all that stuff. This is positive 4 times all that stuff. So let's multiply that out. Ready? Negative 3 times 4x is negative 12x. Now make sure you don't forget this. This is the most missed thing. This is also negative 3 times that plus 3. So negative 3 times positive 3 is negative 9. Now let's move on. I like to distribute, and you should too. Whatever this sign is, distribute it through with the 4. So positive 4 times 6x is, and make sure we start getting the habit of saying it's positive 24x. So that would be plus 24x. Does everybody understand? And now 4 was also multiplied to that 1. So positive 4 times positive 1 is positive 4. Way to listen. You're awesome. And then we have is equal to 43. Now you're to your step of, we've got to combine all like terms on the same side of the equation. So you should not be using inverses. We're just combining like terms. Negative 12x plus 24x is how many x's? 12 x's, right? No, did I say negative 24?
Yeah.
My bad, completely, sorry. Negative 12x plus 24x, right? Is positive 12x's, right? Negative 12 apples.
Wait, wouldn't it be negative?
No. We have negative 12 apples and we add 24 apples. Isn't that in the positive apple direction? Okay, so good, so, okay. And then negative 9 plus 4. Negative 5. And then we have is equal to, so we took care of everything, is equal to 43. And now we're to our step where we just simply get x all by itself using inverses. So our first step is to add 5, right? So 12x equals 43 plus 5 is 48. So I added 5 to both sides of the equation. Now we have 12x equals 48. And now we'll divide by 12. So x is equal to 4. Can we do those ones? Okay. What I want you to do is finish the worksheet. In class it's due. After that it's late. There's no other options. You have to finish this in class. Check it off with me, every single problem. Then you need to get out. If you have not already handed in last time's homework, check that off with me, hand it in. This is all due at the end of the hour, no ifs, ands, or buts. Do you all understand what is expected? Sweet, the rest of the time is yours. Ready, set, go.